All right, good morning, class. This is the Mammo Experience. You're on to grade 11 arithmetic class, and you discover on the board we have logarithm. Logarithm is actually a topic handled in grade 10, and depending on your school, some schools will take it for grade 10 and then move on to grade 11. Some schools clear it out totally in grade 10, like something I try to do too in my school. We clear it out totally in grade 10, and by grade 11, we're taking another aspect of logarithm that has to do with logarithm without tables. That will also be covered in the course of this course, but we'll stick around logarithm with tables. Essentially, the end product of this class is to be able to handle the concept of bar notations, or the spread of this period to handle bar notation. But to keep things smooth and nice, we'll go by trying to have a review on standard form. We said that logarithm talks about the expression of a number, or a log tells us how many times a set, or rather the power to which a certain base is raised. So if I write 10, for instance, 10 will be equal to what? 10 to the power of 1. It means that the log of 10 is 1. 1 refers to the power to which 10 is raised. So another word for indices, or rather for logarithm, is indices or an index. So the logarithm, the index, the power, the superscript are all one and the same word in terms of semantics. They all mean the same. So we can say they are synonyms, all the same when it comes to the understanding of mathematics or logarithm. So in keeping things very simple, we're going to try to review and see how well you remember your standard form. So this is really part 1 of this video, and I'm trusting that you would try to understand what we're doing. So go straight ahead to the board. I have a number of problems which we're going to try to clear out. This is 32.4. We said that the standard form is the expression of a number, a decimal fraction, to become what? A unit decimal times the number of movements you will make. So for this, if I have to write this as a unit decimal, this will become what? 3.24 times 10 raised to the power of. What kind of movement had I made to get this? I've made one movement backwards, so it is what? To the power of what? 1. This is what? I can write this to be 4.71. This is 0.471, which I can write as what? 4.71 times. What kind of movement do I need to make? I'm trying to make a small number big. So it means I have made one negative movement. Technically speaking, when you have numbers like this, if they are big numbers and you try to write them in their standard form, they will have a positive power of 10. If they are small numbers and you try to write them in their unit decimal, they have a negative power. So that's just the field we're going to be applying here. So what I need to do is to write this first. This is 3,472. So I write that times how many decimal places am I going to move? Every whole number has a decimal just after the unit point. So it will be 1, 2, 3, 4, 5, 6. Now look at this. This is a small number, 0.006131. So I'm going to write 6.131 times what's the relevant movement I need to make. I'm going to make 1, 2, 3, 4, 4 movements, and that will be 4 negative movements. Same idea here. I'm going to have 4.576 times how many movements am I going to make? 1, 2, 3. We look at this. This will be 5.172 times how many movements am I going to make? 1, 2, 3, 4. I'm moving backwards, so it will be positive. Look at it. This will be 4.381 times 10 raised to the power of how many movements? 1, 2. 2 steps forward. This will be 2.31 times how many steps? 1, 2, 3, 4, 5, 6, 7. This will be what? 6.23 times how many movements? 1, 2, 3, 4, 5, 6, 7, 8. This will be what? 3.471 times 10 raised to the power of 1, 2, 3. negative movements. If you move forward, negative movements. If you move backwards, positive movements. I come to this. This is already in its unit decimal form, so I'll make no movement. I make no movement for that. Now to this, I'm going to have 5.1 times 10 to the power of how many movements? 1, 2. For this is 6,500. So I'm going to have 6.5 times 10 to the power of how many movements? 1, 2, 3. This is 24.12. And that will be 2.142 times how many movements? 1. That will be positive movements. So we come to this. This will be 2.79 times how many movements? 1, 2. That will be negative movement because I'm trying to make a small number to look big. Now look at this. 1.93. How many movements? 1, 2, 3, 4. Look at this. This will be what? 1.02 times 10 to the power of how many movements? 1. Look at this. This will be 1.28 times 10 to the power of what? 1, 2, 3, 4. Making a big number look small. Look at this. This will be 7.43. Making a small number to look big. So it will be 1, 2, 3. Finally, I have 5.008 times 10 to the power of what? 1, 2. Now, why have we done this exercise? Like you would have seen in our grade 10 experience, if you check my grade 10 videos, your understanding of this topic is tied to your standard form. At least that's the model I'm using. I approach logarithm from the model of standard form. It's taken me years to research and to discover that to understand logarithm, once a student can understand or to write in standard form, every other information you add, the student can easily process and flow. So hence we have come back to do standard form more like a revision. And based on this now, we will now go ahead to continue the course. So you can now write in standard form. That's good. But there's yet another thing. How well can you use your 4-figure table becomes very important. How well can you use your 4-figure table becomes very, very important. Like I said, I'm already developing a video where I just use the 4-figure table only. It's a mathematical table series that will show us how you do different readings for logarithm, cosine, and all. I think it's very important that students should know when you have your table, how do you read? How do you place your hand? What are the things you should do when you're reading on your 4-figure table? All right, so for this one, let's assume you are told to find, because we said that the log talks about the power to which a number is raised. So if I say find the log or logarithm of, let's say, 450. We said that the first step is to write this in standard form. So 450 will be 4.5 times 10 raised to the power of 2. How? Every whole number has a decimal point just after the last digit, and you count 1, 2. So that will be 4.5 times 10 to the power of 2. All right. So the log of 450. Now, because we're dealing with log using 4-figure table, the base is taken to base 10. So if I write the log like this, by the time we do logarithm without tables, you understand this concept better. By the time I write the log like this, essentially what I'm doing is that I'm telling you that the base is 10. Whenever the base is not indicated, it's what? Base 10. So this will be equal to what? If you watch my previous videos on this matter, this will be equal to log of this to this will now be 10 to the power of, checking this in the logarithm table, times 10, or rather this will be equal to, the log of 10 is 2, plus, you go to your 4-figure table, check what is 44.5. 4.5 means what? Check what? On your logarithm table, 45. So what is 45 on your logarithm table? There are different methods to do this actually. And so no matter the approach, I'm going to use both approach to stop this. 45 will be what? In 45 will be 0.6532. So let's change our marker. So for this, it will be 0.6. What's that again? 6532 plus 2, which will mean 2.6532. Now that's one approach. Another approach would be to say 450 will be equal to, instead a number is the power to which a base is raised. So it will be 10 raised to the power of what? From here. It will be 10 raised to the power of what? This answer I got here times this one, which will now be 10 raised to the power of what? 2 plus 0.636532. And that will mean 10 raised to the power of 2.6532. We had said that the logarithm is the same thing as the index. So this is the log. So the log of this, so the log of 450 will be equal to what? 2.6532. But that's not what we are focusing on in this course. Our focus in this course is on trying to remember what this part is standing for and what this part should stand for. Now, we said that the log of a number is the power to which a base is raised. And we said that for using tables, we are concerned with base 10. So if you understand that this part, we call this part the characteristic, and we call this part the mantissa. We call this the integer part. This is also called the integer. And we call this the decimal part. So there's more to that, but I've done extensive videos on this, but just more like a revision to what we've done. Now, this part, we read this part from writing our standard form. So this is usually the standard form readouts. As for instance, when I write 10 to the power of n, n is actually what we are calling the characteristics. This part is the part we call the log table readout. Now we read this part from the logarithm table. So when we write in standard form, we use our logarithm table to read out a certain value. Then we use this one to do another. We use this one. We read this one from the standard form. So if, for instance, like this question I solved before, 450, I write in standard form 4.5 times 10 to the power of 2. This 2 I've written here, it becomes the characteristics of the integer part. When I find the log of this value, this becomes, when I go to this is what I used to do my logarithm table readout. So I read out this value, and what we obtain will be this. See what we're going to obtain. 2, which is the characteristics, point. My 4-figure table gave me what? 6532. The answer you get here must always be decimal. Something rather interesting you must take note of here is this. This part can be positive or negative. It is based on this concept that we will now move into the concept of what is called bar notations. All right.